Hello and welcome to this quick demonstration of using Rapidminer to mine Twitter data. In this particular example, we are going to search Twitter for the word 0-day, which is typically associated with 0-day bugs, which are vulnerabilities that have a significant impact generally in the security space. What you're looking on your screen right now is a dashboard that we have developed using Tableau. The data obviously is coming from a Rapidminer process, but just to show you the output first, right? What we are doing here in this particular bubble chart is showing the typical words that are appearing along with the word 0-day when we ran this process over an extended period of time against Twitter. You'll notice there are some words that appear in bigger bubble, which indicate those words have frequently been associated with the 0-day word while we search. Some of the words that are interesting here is the word modem, then there was flash, there was routers, there was storm, there's obviously headaches, flaws, spawn, and whatnot, right? So this sort of gives you an indication of what were the typical words that appeared when you search for 0-day. So indicating potentially there was a problem with modems, problems around Adobe, there were bugs, and there were problems with routers and whatnot, right? Some of the words probably are just noise, and obviously we can use Rapidminer to clean this up further, but that's not the purpose of this demonstration. But now that we understand, what were the typical words, maybe let's dive deeper to see when did this happen, right? So to do that, I'm going to switch over to my second tab here, where I'm going to show you the trend as it happened. Now, in the initial phase of my analysis, the area where pretty much you see flat lines, this was earlier in November, and you'll notice there is a consistent value of the words as they appeared. Before I dive deeper, the x-axis is actually the timeline, and the y-axis is the word's frequency as it appeared. And at this point, I guess the values themselves don't make much sense, but the idea is the bigger the word, the more closely it is associated with the word 0-day. So you'll notice there's pretty much a flat line with some small ups and downs in between here. However, if you go further along the timeline, you'll notice something interesting around the December 3rd time frame. And also another peak here around the December 4th time frame. If you quickly hover over here, we see the words that were actually kind of associated with 0-day, where things like mobile, flaws, modems, analysis, and so on and so forth, right? So these are some of the words that actually appeared around the 3rd of December time frame, 3rd of December 2015 time frame, when we ran this against Twitter for the word 0-day. Similarly, on the 4th of December, the other words that were popular were Java and attack, right? Interestingly enough, there was actually a 0-day bug found around the 3rd of December around modems. Some of the most popular modems are affected by this. And similarly, there was another vulnerability found with Java around the 4th of December. And as you'll notice, these words were emerging on Twitter, and Rapidminer was able to identify them very closely for you. In a real world, obviously, there are going to be thousands of these words, and it's difficult to sniff through, all that noise to find these patterns. But as you notice here, this is quick insight for anybody who's trying to mine Twitter for specific words. So how did we do this? All of this really happened in Rapidminer's studio client. You could obviously automate all of this using the server client, but for now, we'll focus on our studio client. So let's quickly look at building a very simple process, and then I'll show you the remainder of the process from my pre-built example. But switching gears, this is what my Rapidminer Studio client looks like. As you can imagine, the first thing we need to do is to get the data from Twitter, and Rapidminer has an operator for that called as search Twitter. So I'm going to drag that here and build a simple process here where I'll say search Twitter, use the connection that I've pre-configured. The query I'm going to look for is 0-day. And I'm going to stay with recent or popular 1,000 tweets, right? Or actually, let's stay with 100, right? So this simple operator gets the data from Twitter using its API with any tweet that is associated with the word 0-day. Let's quickly run this to see what it looks like, right? And here we have the results. So Rapidminer is obviously able to pull the tweets, and along with that, the tweets are here. Along with that, it can get other metadata if available around like geolocation, retweet counts, from user, to user, and all that good stuff, right? We could obviously use a lot of these information to make our process more robust and probably find some other insights if certain trends are appearing in a particular geography, if certain people are responsible for making certain terms popular and so on and so forth. But for now, we'll just stay with basic text mining exercise where I'll try to get the data from this text to see what were the trends as they're happening. So now that we have the Twitter data, we'll insert a simple building block, which is nothing but a Rapidminer shortcut way to insert steps which are reusable and used very often. In this case, my text processing capabilities, which involves a bunch of these sub-steps like tokenize the word, transform cases, maybe generate n-grams and filter words and whatnot. I use them very commonly in a text mining exercise, so I just drop them here in one simple click. I connect the Twitter feed as an input, and the output of this is going to be my tokens as well as the word list. By the way, here we configure how we want the tokens. In this case, I'll stay with TF-IDF. One other additional step we'll have to do here is, because the text processing node expects data to be in text format, I will convert my data from nominal to text by dragging an operator in between here and saying I'm going to convert one single column, which is my text column, into a text column, right? Let's run this process and look at what the results look like. So over here, we are going through each and every single tweet and the text of the tweet itself, and then converting those into tokens. This is the word list as it appears in that Twitter search result. If I switch over to the next tab here, which is going to be my actual tweets and tokens, this is what the output looks like. What Rapidminer does is associates the term frequency for every word that appeared in the tweet and 0 where it did not appear in that tweet. But this is a good indication of how frequently a word appears in a tweet. And if you go through the whole timeline and let's say sort by a particular word, these are the words, these are the tweets that have these words and the appropriate density value for that word. We'll later on use this information, these numerical values, to identify trends over a period of time. But now that we have this simple result, let's switch over to what my actual process looked like so that we can fast forward this and look at the final output. My process was built in several steps where I built a process like this and saved the raw tweets themselves in one of my folders on the Rapidminer repository. Then I processed those raw tweets and built tokens out of it and saved them over here. You saw how I was able to do that within a few steps. And then, like I mentioned, we are going to use that individual values to build cumulative sums for each of the runs. To quickly show you that output, let's open one of these results. And what I'm doing here is adding up all the term frequencies for every single word as it appeared. This kind of gives you an overall view of what are the highest, frequently cited words during that run. Now, when you combine this result set of one run with previous result set, you will get something like this. Now you are able to capture the words and watch the trends as it happened. So for example, if I look at the words that appear on this particular day, on the 23rd of October, these were the highestly frequently mentioned words. Now the way the trends actually emerged was on day 3 of December 2015. Let's sort them accordingly and see what happens. So you'll notice on the 3rd, these 5 words kind of popped up very high, whereas in the past they were actually not even mentioned. So modems, bugs, compromised, numerous routers, these are the words that really were highlighted on the 3rd of December, and they were not even mentioned even before that. So this is a very good indicator of something's going on around the modems and the router space. There's a 0-day bug that was actually found around this date. Similarly, if I sort the highest values for the 4th, you'll notice there were a few words that appeared. Again, they're not really a good indicator, and so on, right? Now, you'll notice there are a lot of rows, 3,100 rows, and obviously it's humanly impossible to go through all of them to see the patterns. So later on, what we did is also build a simple Rapidminer process that sees the deviation in values across each of the words, right? If there is a word that has a significant increase or decrease in the number of, in the term frequency over an extended period of time, and then using the standard deviation measure, we filtered out everything except but the top 300 words or 250 words that have the frequencies changing. So that way we can focus on the words that matter. We could obviously keep data for a very specific period of time, let's say for last 3 days or last 2 days or last 24 hours, and that way we can see words that had a change in the term frequencies in that short period of time, kind of highlighting things that are emerging or even getting downgraded. So you'll be able to build a Rapidminer process to do something like that. To show you an example, I'll switch over to a pre-built process and kind of walk you through the summary. Obviously, all of this is available via your Rapidminer representative. So switching to my design tab, I'll quickly show you one of that processes. That process would be looking something like this, where my first two pieces of the puzzle are nothing but just metadata creation so that we can keep track of things over. The next part is this subprocess called a search and save. If I go inside, all it really does is search the Twitter term and then store it. Then we proceed further to build the tokens as we saw earlier. And then once the tokens are created, we also store them back for future processing. Once we have the tokens, then we proceed further to capture the weights, which is a simple aggregation of the word frequency. And then again, we store it and make it available further. And then we do some metadata processing to update it and use it later on. The other process around calculation of standard deviations and then filtering is again using very standard Rapidminer processing, so we'll skip that for now. But the idea here is this simple process can be run as many times as you want at any frequency as you want to capture words associated with specific search terms and see the trends as they emerge. Not only that, we have parameterized this process in such a way that you could pass on a different folder name and a different search term, and we could be reusing the same process to mine Twitter for not just one keyword. We could be running this in parallel for different terms and saving it. To take this one level further, we could go beyond Twitter and mine web pages. We could mine RSS feeds. We could mine other text documents, other resources, and apply the same kind of processing. And obviously, all of this can be run using our server in an automated fashion, and the output can be delivered in Tableau or any other dashboarding tool as desired. So with that quick overview, I hope you find this useful enough. And again, feel free to contact your Rapidminer representative to discuss this or other use cases in details. Thank you again.